I'm Pieter Van Schalkwyk, and I will run you through how energy and utilities do asset optimization using digital twin technology. When we speak to executives in energy and utilities, and specifically around asset optimization using digital twins, we kind of hear the same three questions. What is a digital twin? Why should I care? And how do I get started? So I'll start with what is a digital twin. We were an early member of the Digital Twin Consortium, and in that consortium of 250 organizations came up with a definition of a digital twin is a virtual representation of a real-world entity or process that is synchronized at a specific frequency and fidelity. And the key is that it's synchronized as a visual representation of an entity, which could be a physical entity or something like a business process. It is underpinned by three things, which is it needs to improve understanding, decision-making, and effective action. It needs to use real-time historical data to help you analyze what happened in the past, what's happening right now, and what's likely to happen in the future. Now, digital twins should be driven from a business perspective around outcomes. We create them around specific use cases or applications. They are powered by integration, a key aspect, using data, and guided by specialists who understand the domain where they operate. And typically these are implemented in the industrial environment like energy and utilities through IT and OT systems. If we explain this in a picture, on the left-hand side we have the physical entity or the physical twin. And on the right-hand side we have the digital twin, which consists of a model, consists of data that is synchronized at a certain twinning rate. And during that synchronization, we create an instance or instantiate the digital twin based on the model. I can have one model and 1,000 pumps in this example. And sometimes the digital twin would feed information back to the equipment, but that is not necessary from a digital twin definition perspective, but it does need synchronization from the physical to the virtual side of it. So 50,000 foot view of what it is. Now, you also get very simple, discrete digital twins like a transformer. Not that it's a simple piece of equipment, but you can create a simple digital twin around that, which could be part of a composite digital twin, for example, the substation. And that substation is part of a larger, bigger network, which then becomes a system of systems challenge. And that's how the scope and scale of digital twins and the interoperability challenge with it grows. What does life look like right now without digital twins? Well, operations, maintenance, safety, and all these other functions have their own little systems on the right-hand side where they sometimes duplicate data. They have different systems, and each of them have their own capabilities in different silos. What a digital twin brings, it's really that proxy that allows you to use common capabilities in the middle and then let the different areas of the business create use cases. We'll get back to these 6 core capabilities as you see them there when we talk a little bit later around how to build these things. So just remember the paperclip, we'll get back to that. The second question that we get is, why should I care? Now, again, in energy and utilities, some of the examples here is really around the measurable ROI. And this is how Michael Greaves talks about the impediments of digital twins and why, from an adoption perspective, one of them is that you have to have value-based use cases because accountants are the killers of joy, according to him. And if you didn't know, he was the founder of the term of digital twins. Looking at energy and utilities, and specifically on the asset side, predictive maintenance, according to McKinsey, a study that was done, anywhere between 10 to 20% reduction in maintenance cost, as well as increase in asset availability by 10 to 20%. If you put that in context of your organization, it's massive. Likewise with asset performance management, how do we improve the utilization and the asset productivity? Again, you can see anywhere to 2 and 5%. Now, if we move that into the grid operation side of things, on the transmission side, again, anywhere from 10 to 20 in reduction in grid-related outage times. From Navigant research, if we can now start integrating some of these other new generation or alternative energy sources and we can do that in a structured way, then again, the impact anywhere from 3 to 5% in terms of improvement of getting those online. And lastly, disaster recovery, things like natural disasters and those. How do we recover from that? How do we recover quicker? And this is from the Electric Power Institute, some of the numbers that they have there. There's also been a shift in power. So how we did it traditionally, we had generation units and then we had load units, and it was just a continuous optimization problem. Where we're moving to now, we have generators that are also consumers, and it's a really much more of a balancing act, and we have to sense, decide, and act in a different way. It requires collaboration, orchestration, and a lot more flexibility compared to where we came from historically. Now, in order to do that, and this is from Gartner, to move now where we right now have a limited amount of renewables, as that changes, and how we also centralize everything, even from the decision support and the applications that we use, very monolithic applications and structures that we had, moving into intelligent distributed organizations, recomposable decisions. The way to do that is by one, adopting digital twins in the context of the discussion today, as well as composable capabilities and how we do that. Now, again, this all needs executive support, and we need to drive the ROI. And the levers that they have is really around, and where digital twins can support the ROI on the investment, is to help with these assets around to run more often, to produce more or enhance the output while it's operating or running, improve the integration of distributed assets, and also minimize the cost in the process, all in a framework of enhanced safety and also improving ESG. Across these four key drivers or key threads around business performance, the process optimization, ESG monitoring, compliance, and also asset performance. And this is a strategic initiative set. Now, in order to drive that, a lot of organizations are creating different initiatives. So underneath of those, different initiatives to address that. But the real trick is in moving from a strategic to a tactical and operational side, and thinking about what the decision support and automation requirements are at each level of the triangle to turn the strategy into execution at both the tactical and operational levels. When we look at this from a digital twin perspective, a little bit more hierarchical, you'll see on the left-hand side we have strategic, tactical, and operational. So right at the top, from a strategic perspective, I want to see all those ROI drivers. And I potentially even want to see it across different sites, which may also have a tactical implication. But then I go into the asset health and then the process health or the operational health with the equipment, and again at operational tactical levels. And this is what a digital twin can help you do. And one of the key things is you can create metrics at every level to see how good you are at doing that. Now, a different perspective on this and the role of a digital twin is to create that common operating picture for operational awareness and response. And the whole idea is to change from reactive to more prescriptive operations. And many organizations now in power and utilities and asset-intensive complex industries have a whole array of complex assets where there's already SCADA systems, PLC sensors and everything in there. A whole bunch of different applications inside the organization, ERP, GIS, name them, ML. And then we're trying to use people, processes, and automation to respond to events that happens in all of this context. And there are signals going from the assets into these systems and transactions in terms of what people need to do. And we have subject matter experts that have a deep understanding of these assets and how they operate. Now, what we are trying to do is, first of all, connect to all of those signals and data and create some event intelligence. And in XMPro, we do that through what we call our data streams. So it's a visual way of connecting and handling the integration to all of these complex things around a specific use case or application that we are trying to do. So it's a visual way of connecting the data so that we can create visualization. So looking at the same data at all the different levels, but from a different perspective or different lens. So operationally, I see information. And this is what we refer to as event intelligence. We are now connected to these real-time data streams, and it now feeds our common operating picture with all from the same data sources, but a different lens and perspective at the strategic level, at the planning or tactical level. What's my view for the next two weeks, a month, a quarter, versus what's happening right now at operational level, and what do I need to do right now. And this gives us operations intelligence. So now we've moved from event intelligence to being able to operate in a better, different way. And again, adding some more capability to this is being able to create recommendations that you can consolidate from all of these different places and have a consistent way that you present how people respond to different events that happen, but using, again, a similar structure, whether it's at strategic level, tactical level, or even bringing it from the underlying systems that sits at the bottom. For us, that's the holy grail of a common operating picture, is not just seeing the picture, but to know what to do and have prescriptive recommendations, which allows your smartest people to kind of pull those ROI levers, so they know how to now manipulate those levers, which will reduce the risk of you being blindsided by key events that are likely to happen or happening. And it also improves the accountability and closes the feedback loop that provides visibility and opportunity for learning. And this is a whole new business process. But if I look at digital twins in terms of business processes, this is not new. This is from Gartner in terms of looking, for example, at a digital twin. What we're trying to do is the asset performance management. When something's wrong, we want to raise a ticket for maintenance. We want to make sure that we've got people. We want to know that we've got spares. We want to schedule the maintenance effort, and also create tasks and work lists for technicians to go out and do that. And then at that stage, we can take the asset offline for maintenance. So once we find vibration data that gives us an alert, it goes to full circle. So in a way, that's a similar description, but this is just a business process with a different way of actuating and responding to it. Instead of human-to-human workflows, this is now initiated through machines and IoT and sensors. It's still an analysis process, there's still a work plan process, and there's still the execution of making sure that it's done. And the value sits in improving the yield and in terms of the business outcomes, making it more profitable. From an XMPro point of view, with a common operating picture, it's the same. It's about integrating all of this heterogeneous data in a drag and drop way, and then being able to combine off-the-shelf analytics with maybe some more advanced analytics developed by your own SMEs in-house, getting that into the systems so that you can go and create work orders and things like that in ERP and EAM and some of the other systems, and then create an interactive user experience. And as we're moving into AR, VR, and some of the others, how do we support that so we can help that technician to do the best job, and then verifying and checking that the work has been done, so we can close the loop on this. The next question that we get is, so this is all well and great, but how do I get started? So the way that we get started, and again, this is just based on a concept of composable architecture. There are many different pictures. I personally like this one of Gartner, where it talks about all these packaged business capabilities that sit at the center. So how can we create these reusable blocks, almost like Lego blocks? How can I create all of these blocks and then allow my subject matter experts, where all the data and everything comes from all the existing systems that we have, to be able to compose new applications, and this composition platform can handle integration, orchestration, the UX part of it, the operation and the governance as we go through. And then we just build these applications on top. We've taken that same approach and just applied it to the different types of data and information that we see in the industrial and specifically power utilities environments. So physics-based models, analytics, IoT and temporal data, transactional data, visual models, and master data. As part of this, you can see all the different types of that lives in there. Through that, we can now create packaged business capabilities. So we can have leak detection, we can do current monitoring, we can do as reusable little blocks of capabilities and compose that together to be able to create digital twins. That's where XMPro fit. We see ourselves as a digital twin composition platform that's really good at handling the integration, composition, orchestration, the development of all of this, and the management, as well as the UX part that sits on top of it, while all of this is integrated into legacy business systems, IT systems, OT systems, and kind of the modern data fabrics that we see a lot of organizations implement right now. That enables us to build digital twins for performance management, fault detection, automation, emissions, and different. We can reuse a lot of the things that we've done and the connections and capabilities that we package together in order to do that. From an XMPro perspective, the way that we do that, on the left-hand side, we've got our data streams, which is how do we connect and integrate and compose and orchestrate, and on the right-hand side is more the UX and the UX development in our application designer. So I mentioned earlier in terms of the little paperclip and those 6 capabilities that we saw. Inside Digital Twin Consortium, I had the opportunity to lead a group that created the capabilities of periodic table. And we categorized all the capabilities of a digital twin into 6 main groups, naming data services integration, intelligence, user experience, management, and trustworthiness as the key categories for these. And inside that, for example, with data services, we have data streaming, data transformation. So a whole bunch of core capabilities. There's actually 62. So in integration, on intelligence, on UX, on how to manage all of this, and also from a trustworthiness. This is available on the Digital Twin Consortium website. So I'm not going to drill down into much more detail. You can get some information there, but you can compose any digital twin by using some of these blocks. And it gives, so here's an example of condition monitoring for a wind farm. In this one, I only use these capabilities. And if I want to create energy prediction, then suddenly I have machine learning, artificial intelligence, and some of the other things I need to add, which also helps us to start a conversation around what capabilities do we have in an organization and which of them should we look at building, partnering, acquiring. So there's a whole bunch of things, but it also helps us to also not just focus on the smart technical things, because this is not a technology or this is not an architecture. This is just core capabilities. But some of it relates to trustworthiness, like security, safety, and also how do we handle things like event logging and some of managing these things at scale. So what does it look like as a typical example? So here is that wind farm, and this is a remote operation center. So I can see my overall portfolio of wind farms and solar farms and all sorts of different assets that I have. I can see at the moment they're all green, so I'm pretty happy with those. I can also see key outcomes, and I'll drill into much more detail on each of these, but it's really around how can we make sure that we are outcomes focused, that we provide contextual metadata, context for decision makers. How do we focus on the asset itself and the asset performance? How can we provide advanced analysis as well as collaboration in all of this? And also, how do we provide access to knowledge all in a common operating picture? So with that, I'll get into a little bit more detail on how we compose the digital twins. For us, it's a 3-step process. The first step is orchestrating all of this data. The second part is, and in a visual way, the second part is creating the visual experience. In this instance, it's a desktop app, but it could be mobile, it could be AR, VR, any one of those. And then how do we create recommendations? Because that's a key thing. The real outcome that you're looking for is the actions that come from recommendations. So if I touch on the first part in terms of how we build this orchestration, what you'll see here is typically how we do it at XMPro. We've got a visual drag and drop data stream designer. And with this, I can now bring in information from the rotor and the gearbox, the power, the yaw pitch, all of that from other telemetry using MQTT. These are all draggable blocks under listeners. There's a whole library. It's extensible library. I can drag these on. I can then do and I can bring context like make, model, and all that from Maximo in this instance. I can then transform that data. So there's a whole range, there's a whole bunch of blocks that are all around transformations, doing calculations and all of that. I can add clean, wrangle data in all of that. And then the next step is applying some AI to it. You can see I'm running a Python model to predict likelihood of failure. There's an anomaly on the right, top right. I'm also storing some data at the same time here in InfluxDB. as an action, which is action agent. And on the right-hand side, we then run a recommendation, which is also, there are different variations, all blocks that I can drag on. So this is a visual way to build, and then the data flows based on the frequency that I'm specifying for this as well. What we've added to this now is the ability to bring in Jupyter Notebook. So we have our AI designer, which is embedded in the product as well. So I can run some of that logic, advanced logic, create models, simulations, all of that, running Jupyter Notebooks as part of that data stream, which is a key part of bringing intelligence to data, to digital twins. The next part is to make it look pretty. So the visualizations, as I mentioned, you can bring in objects from external things like GIS systems, example of Esri here. There's some, and also recommendations from the recommendation engine showing me where there are potential challenges. This is outcomes focused, so you can see core metrics. Are we doing better? Are we getting worse? What's my current view on open work orders? And I can see the health and across my different assets pretty easily. If I get into the asset itself, I can start looking at the time profile, some of the calculations around effective utilization, the power that it's in, current real-time yaw and pitch and all that. I can see some of the other live metrics, the recommendations specifically for this one. This could be a 2D graph, or it could be a Unity model, or it could be an Omniverse visualization. And I also have my maintenance records from my work order history and everything as a common operating picture for someone who needs to make a decision right now. I may want to do further analysis on this, compare different turbines in the same wind farm to each other, or I need to have contextual information around what's happening right now in the environment. I may need to speak to someone from the supplier of these, or someone in our operation centers around some issues that I'm seeing there. I may have to get some documentation and supporting information around this. And where this is all heading, as you've seen with things like ChatGPT, and what we're baking in as well, is the ability to now use that and interrogate and say, for example, what are the failure modes and what are the root causes potentially for what I'm seeing here. So that's where this is heading. And this is all as part of the visualization part in the middle. The next part is being able to create these recommendations. And in this instance, I can just see some of the real-time data around what happened. And then I can create a work order in this instance. So this will automatically then create the work order back into my existing system that I have, like SAP or Maximo or whatever it may be. And I can do some analysis on how many times we've seen this across this equipment. So a lot more to this. I'm just skimming over this pretty quick, but that's kind of the other core element of an interactive digital twin. Which leads me to, where is this all going? So what is the future? And again, I had the opportunity to work with Dr. Michael Greaves at the Digital Twin Consortium. And he's got this view of intelligent digital twins. For me, it is an integrated, intelligent, interactive, composable environment that we need. So we need to make sure that it's standards-based API models, as I showed at the past. We need to make sure. And what we're seeing is executable AI, as I've shown you, where we've got the Jupyter notebooks and those embedded, Python running inside, so I can get the smarts of my engineers into those data streams. The innovation AI, being able to run things like front-running simulations, similar to what we have in Formula One, where I can speed up the environment and kind of see what's likely to happen. Again, this is all possible right now. And then augmented AI for making the digital twins smarter. So putting AI over the data that we're collecting and see how can we improve and make them smarter, so we can get some machine intelligence out of this. From an interactive point of view, looking at making it more AI enabled, so that for recommendations and prescriptive analytics, creating multi-user experiences that are more collaborative, generative. And then also, we don't know where the industrial metaverse is going to end up or what it's going to look like. But the digital twins will be the core building blocks for the industrial metaverse. And all of this in a composable way, so we can reuse what we're doing.